Here I'm gonna making videos about quadratic, which is there are four main things that you are gonna study, which is about factorizations or factorize the the quadratic expressions or algebraic expressions, and the second is complete a square, and fourth is quadratic formula and the discriminants. So quadratic formula, which mean it's about equations. Okay, so first let's go to factorize. So factorize, I mean, what is factorize? Factorize is like this. It's like we making something, we making like something to be something which is about multiplication. For example, I have 4x squared plus 2x, right? You can see this is 4x squared plus 2x. So it is an algebraic expression which is quadratic, but it is sum. Yeah, it is just a sum, you know. But if we factorize it, which means it's gonna be 2x, okay, like 2x plus 1. This is called factorizing. And then you can just see this is one factors and another factors. So we can concluding by factorization is like what? It's like the way that we write something, or we write an expression from sum or subtraction to be multiplication of factors, which is like you can see this 2x and 2x plus 1. So 2x is one factors and 2x plus 1 is another factors. So we consider that is called factorizations. But what if we making like, okay, like plus 2? This is not called factorizations because it makes with sum. So factorization, like I said, is making or swap or changing from sum or subtraction to be multiplications of factors. So in quadratic form, in quadratic, you know, it's like the general or the standard is ax squared plus bx plus c. So at first, okay, for example, for x plus 2x, it is it is possible to factorize it. But for something like 2x square minus 4, okay, actually we can, which is 2x square and minus what? Minus 2, and we can also factorize it as x minus square root of 2 and x plus square root of 2. Okay, which is what? We just use a square minus b square equal a minus b times a plus b. We use here, okay, and then we can factorize it. Okay, so can I say, can all quadratic be factorized? Actually can, but not all. You understand what I'm saying? Not at all. Okay, not at all. So like this, okay. But what about this? X squared minus 9. So like the previous here, the previous example, I give you x squared minus 2. So we can apply a squared minus b squared, or we can apply x squared minus a squared. It's gonna be x minus a times x plus a, which is we can make 9 to be something square, or something square or perfect square. So it's gonna be x squared. We can write it as 3 square, and it can be written as x minus 3 times x plus 3. Okay, so this is this is what we can like what we can factorize in quadratic. Like you can see there are 2, 1 and 2, 1 and 2, 1 and 2. We call it polynomials. So we can factorize it when there are 2. What can I say? It's like there are two terms. Yeah, there are 2 terms. Okay, we can factorize it. But what if there are 3 terms in it? Okay, for example, like x squared plus 2x and minus 3. So for this case, we can factorize it by what? Actually, first of all, you should what? You should find, okay, -3, right? So -3, you should find any multiplication of 3 that that the sum of both equal to +2, which is what? Which is we have to make, or we have to find any multiplication of two numbers that equal to -3, and then we check whether both of them added together equal to 2 or not. So for me, I can just -1 times 3, okay, they are pairs, and 1 times -3. So there are two pairs, which is -1 and 3, and 1 and -3. So among both, among all of them, so one of them, or can I say one pair can be what? Can be 2 after we add together, which is -1 and 3. So we choose this, and then we split, because 2 equal to 3 minus 1, so we can just x squared plus 3x and minus x here, see, and minus 3. So then it's x squared, okay, x squared, we can set x as the common factors, and then x plus 3, and set negative as common factors. It's gonna be x plus 3. So then we can gonna be x plus 3 and x minus 1. So this method is like a method that can be used when when the multiplier of -3 can be 2 after they adding together, but not all case can. I mean, actually we can apply, but I mean it doesn't. What can I say? It's like not all quadratic can use this method, because sometimes the number here, multiplier of like multiplier that make -3 or make something at the end cannot be 2, or cannot be the middle after they add it together. So for example, if I have like x squared plus 2x and minus 100, can you see? So this here can, if we try to find the multiplication that can make -100, so we might not found any multiplication of numbers that can be 2 after we add the multiplier together. So that is what I mean. So this method can be used for some case that it is possible. Okay, so that's it for factorization. So here for this, it mean what? We can say what? The middle, which is, I can just say b equal to something equal to c. Like I can just say, or I can just say b equal to sum of multiplier of -3. I can reason, yeah, the middle. So we can, okay. Actually, for first, that's it, factorize, and for the second is completed square. So completed square, why we use completed square, or what completed square used for? So completed square for quadratic is always used for finding like vertex. Okay, like you know, the standard form is ax squared plus bx plus c, right? But the thing is, there's another form, it's called vertex form. So the vertex form is y equal ax minus h squared plus k, which is what? Which is need us, or which is which is required us to apply the completed square in order to make it to be vertex form. Okay, so how to complete a square? So actually, let me tell you, completed square can be used for factorizations and also finding vertex form. That's it. So like here y equal to x squared plus 2x minus 100, right? Actually, we cannot factorize this by using this method. But we can factorize this by using completed square. And let me tell you how. So here, this, first of all, you focus on x. Okay? Focus on x. And then this x, and this is plus, right? Plus, and half of this. It's gonna be what? It's gonna be 1 square. We focus on two of them only. Okay? And then we minus this square, 1 square, and minus 100 that we have. So it's gonna be x plus 1 square minus 101. Actually, it is vertex form, okay? But we can also use this vertex form to factorize, okay? To factorize it by what? So actually, as you know, if x squared minus a squared equal to x minus a times x plus a. So here we have something square. Okay, like we can compare to this, it's like x squared, and we need a square. So we have to make 101 to be something square. Actually, 101 is not perfect square. So we can make it to be something square, can't we? I think we can. Actually, it's gonna be x plus 1 square minus square root of 101 square. See? And then we can apply that. So y equal to x plus 1 minus square root of 101 x plus 1 plus square root of 101. That's it. We can factorize it. That's all. And for C, quadratic formula, we can use quadratic formula for what? So actually like this. If we have x squared plus 4x minus 5 equal to 0. So you might use to study like, or you might use to solve the equation, or question like x plus 2 equal to 0, and then you can just rearrange it and x equal negative 2. But what if there's x squared like this? There are three terms in that: x squared, 4x, and negative 5. And what we're gonna do with that? Actually, in quadratic equations, we can use quadratic formula, which is what? Which is the which is the roots of these equations. If the equation is like ax squared plus bx plus c equal to 0, then the root is x equal minus b plus or minus square root of b squared minus 4ac divided by 2a. Okay, you can apply that and you're gonna find x equal to 1 or x equal to negative 5. Yeah, that's it. And then oh wait, let me tell you, you got this by applying this, which means you can plug b, which is 4. We know that b is 4, a is 1, and c is negative 5. Okay, you can plug in that and then you can find the answer, like x equal 1 or x equal negative 5. About number 4, discriminants. Discriminant is like this. It's like we use this to check if what? If the equation has two roots, one root, or no roots. So if we have the equation like ax squared plus bx plus c equal to 0. So we don't know a, we don't know b, and we don't know c. So we want to investigate when this equation has two roots, this equation has one root, and no roots. So what should we use? We use what? We use b squared minus 4ac. If b squared minus 4ac positive, that means there are two roots. Okay, then this here is called discriminants. And if b squared minus 4ac is equal to 0, that means one root. And if b squared minus 4ac is negative, which means no real root. Which is no real root. What does it mean? I mean it's like this. When it's positive, there are two roots, which means both of them, or both of them are real roots, which means those roots are real numbers. Real numbers, which mean any numbers. And one root, but no real root, which means the root will be complex number. That's it. You can search about complex number as well. So there are four main things that you're gonna study about, like quadratic formula. Oh wait, I forgot to teach you how to, I forgot to explain you about the vertex formula. So the vertex formula is like this, which is y equal ax minus h squared plus k, right? So as you got y equal to x plus 1 minus 1, 0, 1, right? So which means h equal negative 1 and k equal to negative 1, 0, 1. So then we gonna get the coordinates of the vertex, which is v, negative 1 and negative 1, 0, 1. Okay, this is coordinate of the vertex. Bye. Thank you for watching.